Hello! In this video, I will be teaching you how to do a t-sample t-test for means using an example in the textbook. Please refer to page 639. We will be solving the following question. Does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part of the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is a decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative response. Here are the data. Do the data provide sufficient evidence to conclude that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. So, by following the 4-step process, we begin with the first step, to state. So for this question, we want to carry out a test where mu1 is the true mean decrease in systolic blood pressure for healthy black men, like the ones in this study, who can take a calcium supplement, and mu2 is the true mean decrease in systolic blood pressure for healthy black men, like the ones in this study, who take a placebo. Since there is no significance level stated, we will use an alpha level of 0.05. So for this experiment, our null hypothesis will be mu1 minus mu2 equals 0, which is essentially the same thing as mu1 equals mu2. And our alternative hypothesis will be mu1 minus mu2 is greater than 0, which is essentially the same thing as mu1 is greater than mu2. So step 2, to plan. If the following conditions are met, then we will be able to carry out a two-sample t-test for mu1 minus mu2. The first condition that must be met is the random condition. Since the 21 subjects were randomly assigned to two treatments, this condition is met. The second condition is a bit more complicated for this problem. For the normal condition, since the sample sizes are so small, we have to examine the data to see if it's reasonable to believe that the actual distributions of differences in blood pressure when taking calcium or placebo are normal. We will do that on the following slide because we have to look at the graphs. The third condition is the condition of independence. Since this was a random assignment, the two groups of men can be viewed as independent. And also, individual observations should be independent because knowing one subject's change in blood pressure does not reveal anything about another subject's. So, let's take a look at the graphs. Let's look at the first one, A, the box plots. So when looking at this graph, we can see that there are no clear skewness or outliers. So that's good. Moving on. So to the second one, the normal probability plot for the placebo group, it looks very linear. So that's also good. Now for the third one, the normal probability plot for the calcium group, we see some slight curvature in this, but it's still approximately normal, and we don't see any clear outliers or skewness. So this should be pretty accurate. Thus, we are going to consider the normal condition met. So, moving on to the third step, the do step. So from the data given, we calculated the following summary statistic. So for group 1, the calcium group, the sample size is 10, and the sample mean score is 5.000, and the standard deviation is 8.743. So for the second group, the placebo group, the sample size was 11, and the sample mean was negative 0.273, and the standard deviation is 5.901. We made this chart so the calculations that are upcoming will be easier. So now we will calculate the test statistic. So t equals the mean of sample 1 minus the mean of sample 2 minus mu1 minus mu2 all over the square root of the standard deviation of 1 over the sample size of 1 plus the standard deviation of 2 over the sample size of 2. So to the right, we plugged in the values that we found on the other page. And as you can see, mu1 minus mu2 is 0 in this case because that is the null hypothesis that we are testing. So this gives us the value of 1.604. And we need to find the degree of freedom, which is the smaller n value minus 1. So in this case, the smaller n value is 10. So 10 minus 1 is 9. Now using a calculator, we will convert the test statistic into a p-value. So we use the command tcdf, and we plug in negative infinity 1.604 and 9 for the degree of freedom. This gives us a value of 0.92841. However, since the hypothesis that we are testing is whether it will be greater than 0 or equal to 0, we need to find the opposite value, because plugging into the calculator, this will give us the value of mu1 minus mu2 being less than 0 when we are looking for the chance of it being greater than 0. So thus we just do 1 minus 0.92141, which gives us 0.07159 as our p-value. So the final step, conclude. So since 0.0719 is greater than the alpha level of 0.05, we failed to reject the null hypothesis. So this experiment does actually show some evidence that calcium reduces blood pressure, but the evidence is not very strong, given that 0.07159 is not much larger than 0.05. So thus, we do not have enough evidence to conclude that calcium reduces blood pressure more than the placebo does. And that's how you do a two-sample t-test for difference in means.